ఇందాక మీ స్టూడెంట్ ఇంట్రడ్యూస్ చేసినట్టుగా నేను 1975 నుంచి ఇస్రోలో పనిచేస్తున్నాను. ఇస్రో 1963లో కరెక్ట్గా 50 ఏళ్ల క్రితం డాక్టర్ విక్రమ్ సారాభాయ్ నేతృత్వంలో మొట్టమొదటి చిన్న రాకెట్ తుంబా నుంచి లాంచ్ చేశారు. అది రాకెట్ అమెరికా USA మనకి ఇచ్చారు. 3 దేశాల ఆ లాంచ్కి మనకు కావాల్సినవన్నీ కూడా వాళ్ళు డొనేట్ చేశారు. ఒకటి USA, ఇంకోటి ex-USSR, మూడవది ఫ్రాన్స్. ఒక దేశం రాకెట్ ఇస్తే ఇంకో దేశం రాకెట్ లాంచర్ ఇస్తే, ఇంకో దేశం కంప్యూటర్ హెలికాప్టర్ ఇస్తే, ఇంకో దేశం అది బటన్ ప్రెస్ చేసే ప్యానెల్ కూడా ఇచ్చారు వాళ్ళు. అవన్నీ ఇంటిగ్రేట్ చేసి 1963లో ఫస్ట్ చిన్న రాకెట్ ప్రయోగం చేశాం. ఇవాళ 50 ఏళ్ల తర్వాత 2013లో మన ISROకి, ఇండియన్ స్పేస్ రీసెర్చ్ ఆర్గనైజేషన్, ఐ విల్ స్విచ్ అవుట్ టు ఇంగ్లీష్ ఫర్ ది సేక్ ఆఫ్ ది సో మెనీ స్టూడెంట్స్ విచ్ మైట్ హ్యావ్ కమ్ ఫ్రమ్ outside of Andhra Pradesh. Today, ISRO after 50 years has got 2 launch vehicles of its own design, 14 communication satellites in the geostationary orbit, manufactured in India, aeronautical engineering, materials engineering, structures, control, electronics, chemical engineering, meteorological engineering. You take any field, something like 20 to 25 engineering fields we should have masters in that. And there should be leaders who can do multidisciplinary engineering. Second, no individual can achieve great projects anywhere in the life. It's a great teamwork is required. In ISRO, 16,000 people work, and in outside of ISRO in the industry, another about 20,000 people work. So any success is the result of 30,000 people. తెలుగులో అయితే సమిష్టి కృషి. ఇది ఏ ఒక్కరిది కాదు. ఒక్కొక్కళ్ళు ఒక గంటలో ఒక రాకెట్ తయారు చేసి లాంచ్ చేసేయడము, ఒక గంటలో శాటిలైట్ని తీసుకొచ్చి కొట్టేయడము, అటువంటివి సినిమాల్లో జరుగుతుంటాయి, ఇంకెక్కడ జరగవు. ఓకే, నిజ జీవితంలో కొన్ని ఏళ్ళు, కొన్ని వేల మంది కష్టపడి పనిచేస్తే ఎన్నో అపజయాలు, ఎన్నో ఫెయిలియర్స్ని తీసుకుని, మీ చైర్మన్ చెప్పినట్టుగా ఎన్నో ఫెయిలియర్స్ నుంచి లెసన్స్ని తీసుకుని అన్నీ కరెక్ట్ చేసుకుంటే కానీ సక్సెస్ రాదు. సో టుడే వీ ఫీల్ పీపుల్ హూ హ్యావ్ స్టడీడ్ from India, and incidentally almost all the engineers and scientists who work in ISRO are the people who studied in India, who studied in Indian universities, Indian engineering colleges, and who have, most of them come from middle classes, from poor families and from villages, not from great institutions. Okay, most of the engineers who had studied in great institutions have gone to great countries to contribute there, not here. We are all here and contributing. Now I'll tell you a few examples. We had, as 2 times, I'm very thankful to you, twice you have applauded the success of geostationary launch vehicle GSLV D5 of ISRO on this month 5th. Before that, we attempted a launch, same launch, on August 19th. And any launch vehicle, especially GSLV, takes about 4 months work right from the beginning. So we started the work on January of 2013. So August 19th is the launch. August 18th we started the countdown. After so many months of thousands of people work, we bring it to the launch pad. We bring it to a launch pad which is 1 kilometer from the assembly building by driving the vehicle. The launch vehicle, which is weighing about 200 tons, will be sitting on a steel platform which is weighing 600 tons. The whole 800 tons will be driven to the launch pad in 1 hour time. And we start the countdown after a few days. There will be 112 connections between the tower which stands as the launch pad to the launch vehicle. All 112 connections will come off when the rocket goes up. Out of that, we connect them for giving the cool air, for giving the gases, for giving the propellants, so many things. And in the countdown, we fill 206 tons of liquid propellant in 29 hours, and then 12 tons of cryopropellant. On that day, August 19th, we have completed filling. All through the night, we have filled 206 tons of propellant from 10 kilometers distance, because we can't be near, because those propellants are highly toxic. 50 milligrams of that propellant in 1 kg of air, if the people breathe in, they will die immediately, fatal. So that means one drop spills anywhere when we are filling the liquid propellant, the people cannot be nearby. So we fill it from 10 kilometers distance through a big computer network, operating thousands of valves with number of safety things. So we filled 206 tons of propellant. Then we have filled almost 12 tons of cryopropellant. Then we have to take one stage from 2 bar pressure to 4.5 bar. We have just initiated that, and I went to the mission control center to coordinate other activities. Suddenly I got a call saying that somebody wants to go to launch pad to just check something. I said, okay, you wait, I will see whether launch pad condition is safe for you to go. So we have about 50 video shots of launch pad near around, which will be present to me to show the condition of the launch vehicle and launch pad. One by one I was seeing, suddenly I started seeing some liquid falling down. And then I was surprised, and then looked around, there is no rain. And it is one of the propellants which looks like a water, because the aluminum tank made of 7020, which had withstood 2 times the testing earlier, just cracked when its pressure is taken up. And 800 liters of propellant had come out from the stage before we could stop it and could quickly download all the propellants. You know how toxic it is to just neutralize, to avoid an accident on that day, a launch pad fire and a launch vehicle fire. We have immediately, within next 10 minutes, we have pumped 170 tons of water onto the launch vehicle. Next day, continuing that evening, we have pumped another 270 tons of water. After second day, I was the first person to go near to the launch vehicle to see whether the air is pure enough for people to reach. Then we have removed wherever that stage cracked onwards below, all the stages. So 4 liquid strap-ons we have removed. 1 solid strap-on carrying 139 tons of propellant we have removed. We have removed second stage. We have rebuilt the vehicle, and then again readied everything and brought this to the launch pad, and we are launching. You can see the type of tension we will have under that type of conditions, because for the media or for the people or for the leaders, what they see is a result of that 17 minutes after it takes off. But for us, it is months and months of work. So this is how is life. It's the best time for you to enjoy like this at this age. So enjoy fully, because you can't enjoy like this later. You can enjoy later in a different way. We enjoy working, we enjoy reading, we enjoy sometimes fighting with others. All those things you will also do, but you will do it at a later stage. At this stage, what is the best is you enjoy like this in these festivals. So I also studied like you long back. In 1974, I finished my engineering final year. At that time, engineering students who comes out of his room without inshirt, without shoe, without a proper dress will not be allowed to come to the college. That is the type of discipline. So when I was in final year, I was having a coffee in the canteen. A lecturer, final year we used to have one subject called business management and industrial economics, which normally they used to call from some arts college lecturer or professor and ask him to take the class. And engineering students, most of them never used to attend that class, okay? So that lecturer saw me in the canteen in front of so many students and then said, "Are you Mr. MYS Prasad?" I said, "Yes." "You are not coming to the class at all. I will fail you. You do not know how to come to class and study. Okay, you must know economics is very important." I said, "Yes sir, thank you. Can I come and see you in your room?" He said, yes, you can come. And he went away in a hearty mood. Then after half an hour, I went to his room, closed the door, sat in front of him and told him, what nonsense did you talk in the canteen? I'm an engineer. In few months, I'm going to become an engineer. I know better academics than you. If you talk to an engineer, you better talk first you know how to talk to an engineer in the front of others. Then I said, okay, sir, I'll take leave. Tomorrow onwards, I'll come to class, and I went off. So that lecturer asked another lecturer, what is this in our arts college? People shout when there 100 people are there, and when alone they come to that lecturer, they'll be very submissive. Here we find he is very submissive in front of all the people and came to me alone and then shouted at me. Then they told, this is what engineers are. Engineers maintain their dignity and others' dignity in front of others. So there is a first lesson in management is if you want to motivate somebody, praise him in the public. If you want to fire him, call him to the room and fire him. This is the first lesson in the management, okay? So, and interestingly, I had quite challenging time all through my life in ISRO. I had worked with a number of ISRO chairmen, Professor Satish Dhawan, Professor U.R. Rao, Dr. Kasturi Rangan, Dr. Madhavan Nair, and now Dr. Radhakrishnan. Each of them given me an excellent challenges. I represented India in space in the United Nations for 11 years. During that time, there was a discussion on what to do with the space debris. Whatever we leave in the space, when they become useless material, they create nuisance because now International Space Station is there with 7 astronauts always. Suppose if something comes and hits it, it's finished. So what to do with that? And the developed countries like Japan, USA and Germany came forward with a solution that there should be a standard. It should be implemented legally, internationally. There should be an international supervision, and the people should be limited how many launches they do. It's almost through, except Indian delegation. We studied it carefully and we took strong objection to that. We said, no, you have created the space debris because the ex-USSR used to launch 110 launches per year. That means every 3 days one launch for 1 decade. Nobody else had done that like that. And USA used to launch about 60 launches per year. So we said, you created the space debris. You cannot stop us from launching. You cannot put a standard over us. You can't put a committee over us. Otherwise, we would have got another IAEA. We fought 7 years. India took the lead. We said it's not standards, it should be guidelines. It should not be international legally liable, it should be voluntarily implemented by countries. You cannot come and inspect us, we will inform you what we are doing. After 7 years of fight, in 2007, whatever I proposed, whatever ISRO proposed is accepted by all countries and it is approved by United Nations General Assembly. And that is called today Space Debris Mitigation Guidelines, which we are following. These are all possible. In India, we have 2 great things. One is we had good education system, much better now than what we had. And we have a culture of commitment. We just don't change the job because somebody else is prepared to give a few thousand rupees more. And third one is ISRO enjoyed good support from every government so far, irrespective of the parties. And once, when I was when I was abroad, a diplomat at a very high briefing called me for a lunch, and hints were dropped to me that the discussion is to ask India to sign MTCR. There is an agreement called the Missile Technology Control Regime, which we are not signing. So I checked with the government of India, that means our chairman and the minister. They told me, no, we can't sign. You have to somehow manage it. So normally in the diplomatic circle, somebody calls you for dinner or lunch. Saying no is not a normal practice. So I had to go to lunch, but I should not accept for MTCR. So best thing I decided is I should not allow MTCR discussion itself to come up. So what I did, I went for lunch. Then I started with the normal, usual things. I started with the Indian gods and how do we pray. And then I told there is a god called Krishna. He has got, the Purana says he has got 16,000 wives. So I'll tell you how he married the first wife, Rukmini. Then I told the whole story for about 1.5 hours all through the lunch. And then by the time lunch was over, then I got up. Then that diplomat from the other developed country told, Prasad, by this standard, I should have another 15,999 lunches with you before we come to the subject. Okay. So sometimes our gods are very useful to us. Okay. So friends, I just want to once again tell you the achievements of ISRO are the collective teamwork, where 10 experts continuously all through 29 hours sit and look at about 24 camera views continuously every second to see whether there is anything abnormal. Because it was too much of excitement. In the excitement, everybody was thinking everybody is looking at it, and we all missed it for 5 minutes. So we didn't want to repeat it. Within these 4 months, we have created another facility where 10 experts sit and look every second what is happening at the launch vehicle. This is how we correct ourselves. And we also have many people ask a question, how ISRO could be successful. ISRO could be successful only because of 2 reasons. One, we truly believe in teamwork. We don't think that great things are achieved by individuals. Yes, individuals are important, and the individuals are important to lead the teams, but the teams do the work. Second thing, core competence technology. Technology, if you do not have technical knowledge, if you do not have engineering knowledge, if you do not have sufficient depth to make it, we will be continuously dependent on somebody or other. We should make completely indigenous systems everywhere. India has got great potential. India needs manufacturing technologies. India needs growth in the agriculture, education, and health